You know, when you think of a math test, you probably picture a long list of calculations, right? Well, in the world of the mathematical Olympiads, the problems, they look a whole lot different. It's less about just crunching numbers and more about, well, cracking a code. Okay, just take a look at this. It's a system of three equations with three variables, x, y, and z. And at first glance, I mean, it is a beast. It's this tangled mess of fractions and squares. Seriously, how would you even begin to attack this thing? For most of us, this looks completely impossible. If you tried to solve this with the algebra you learned in high school, you'd end up with an absolute nightmare of an equation. So the real question isn't what's the answer, it's where on earth do you even start? And that question, where do I start, brings us to the core secret of Olympiad math. See, it's designed to test something totally different from what you'd find in a typical classroom. It's not about how well you can calculate, it's about how elegantly you can think. And check this out. This quote from the preface of the textbook these problems come from, it says it all. It talks about flexible and rigorous thinking, but the key part is starting from intuition. This is not about memorizing a bunch of formulas. It's about a creative, deep dive, getting to the very heart of a problem. So here's the crucial thing. We have to just throw out the idea of winning by brute force calculation. The solution to these kinds of problems is almost never a long, complicated grind. It's usually a single, brilliant idea, some unconventional trick that makes the whole thing just fall into place. And to show you exactly what I mean, we're going to look at a fundamental technique they use in these competitions. Think of it like a secret weapon. It lets you completely change your perspective and see the hidden simplicity in a problem that looks hopelessly complex. All right, let's try it out on a new puzzle. Here's another one of these fractional equations. Looks pretty messy, doesn't it? You've got some ugly fraction plus its reciprocal, and it all adds up to 3. Now, your first instinct might be to find a common denominator and start multiplying everything out. But hold on, let's pause and just look for a pattern. The technique we're going to use here is called substitution, and it is so powerful. The whole idea is to take a repeating, complicated chunk of an equation and just replace it with a single, simple letter. It's like you're stripping away a disguise to see the true structure underneath all that noise. And boom, this is that aha moment. If we just replace that whole complicated fraction with the letter y, the entire equation instantly collapses into this. Y plus 2 over y equals 3. And that is just a simple quadratic equation that pretty much all of us can solve. Suddenly, the problem isn't scary at all. It was just wearing a really clever disguise. Okay, so now that we've seen the power of changing our perspective with a simple substitution, you ready? Let's go back to that impossible problem from the beginning and see how this all connects. Let's put our new tool to the test. On the left is our original monster. But now look really closely at the image on the right. Do you see it? That exact same structure, 9 times something squared over 1 plus 9 times something squared, it shows up in all 3 equations. It's the same pattern, just hidden inside a bigger system. Because we can spot that repeating block, we can define it as a function. Let's just call that whole expression f of t. And just like that, our super intimidating system of equations transforms into something, well, kind of beautiful and simple. F of x equals y, f of y equals z, and f of z equals x. Now, we haven't solved it yet, but we've unlocked it. It's not really an algebra problem anymore. It's about understanding the cycle of this function. So, why does any of this matter if you're not planning on competing in the Math Olympics? Well, because the real prize here isn't a gold medal. It's learning a whole new way to think. This kind of thinking is a universal tool. It doesn't matter if you're a programmer trying to simplify your code, an entrepreneur looking for a new angle on a business problem, or even an artist trying to figure out a new composition. The core skills are exactly the same. It's about reframing the question, spotting that hidden pattern, and finding that one simple, elegant shift in perspective that makes everything click into place. So I'll leave you with this question to chew on. What's some complex, tangled-up problem in your own life that just seems impossible right now? Maybe it's not the monster you think it is. Maybe, just maybe, it's waiting for you to find that simple substitution, to change your perspective and reveal the elegant solution that's been hiding there all along.